This is tutorial 8A question 3. We're given a z in rectangular form. Remember there is a complex conjugate term here. So it's 1 plus 2i. Therefore z is actually 1 minus 2i. We're asked to find a z to the power of 4. And therefore to find z to the power of 4, we will not advise you to just do 1 minus 2i and then you do it 4 times. That will be difficult. Instead, what we are asking you to do is to use the De Morph's theorem, convert z into the polar notation here, where we have the absolute value and the angle theta, and then we can then apply the De Morph's theorem, which simply says that when you have z and you want to do it to the power of n, then the modulus will be to the power of n, and the angle will be multiplied by n. So once you can convert the rectangular form into the polar form, then things are relatively straightforward. Okay, how to find the magnitude? The magnitude of z, we call it r. So what we want you to do is to sketch 1 minus 2i. So this is 1 along the real axis of z, and this is the imaginary axis of z, and therefore we have 1 minus 2i. So this is the point that we are talking about, z equals to 1 minus 2i. Now, therefore we have theta, and we can calculate theta very easily. Theta is simply arctangent of 2 over 1. Now let's ignore all this minus 2 plus 1 or whatever, because we can't see where the angle is, and you will get 1.107 radian, and because we are drawing it clockwise, then it is minus 1.107 radian. That's it. So we can now have the magnitude through the Pythagoras theorem, which is 1 square plus 2 square, square root, and we have also the theta. Now once we have z in this form, then it is very easy. We just plug in the De Morph's theorem, and voila, we can get the answer. Square root of 5 to the power of 4 is 25, and then 4 times this angle is minus 4.4 radian. Now, we don't like things in this form. We have something called a principal value. So I need you to sketch where is minus 4.428 radian, which is minus means a clockwise direction. Positive angle is the anti-clockwise direction. So we'll loop up here, and therefore, because this is greater than pi, we prefer to have the principal value from 0 to positive pi. Okay? So we always want things to be between minus pi and pi. So therefore now we can calculate this angle, the real theta, as 2 pi minus 4.428, and we have 1.85 radian. Okay, so therefore this is the final answer in the complex exponential form. And we have the magnitude and the angle. And of course, if we want it to be in the trigonometric exponential form, then this is it, a trigonometric polar form. So we just remember, ej theta equals to cosine theta plus j sine theta. That's it. So we are just putting the angle here, cosine theta plus j sine theta, multiplied by value. Alright, that's it.